Dear students, other viewers and listeners, you are welcome again today to this second lecture, which is about fuzzy logic, why and what. In the first 45 minutes, we discussed some of the issues about solving problems with the help of computers. We emphasize that knowledge is a very important component in order to solve particularly difficult problems with the help of computers. In the process, we also explained that knowledge need not be always precise. It may be imprecise because of various reasons. And we told that this type of knowledge is also essentially forming a part of the given knowledge for solving difficult problems. One type of uncertainty in knowledge is which we call linguistic imprecision. This is an advantage for the human beings that we use just word for thousands of different precise concepts. Like a tall person, maybe 5 feet 10 inches, maybe 5 feet 11 inches, and there are almost infinitely many heights between 5 feet 10 and 5 feet 11 and beyond us. However, for all these infinitely many heights, single word tall suffices for many practical reasons. However, when solving problems using this type of representation, imprecise knowledge may become a problem. So, in order to handle this type of imprecision in knowledge, a new discipline has emerged which is called fuzzy logic, fuzzy representation of knowledge. So, in this talk we will be discussing various issues related to fuzziness of knowledge in representation. So first of all, we enumerate the topics which we will be discussing today, and then we'll go one by one with the various topics enumerated on the next slide. Please look at the slide. First of all, we'll discuss the intrinsic concept of fuzziness with some examples. Then what is a fuzzy rule? We have a rule. If somebody is above this much weight, then this is there. Like this one, if one has more than 60% marks in chemistry, physics and mathematics, then he or she is eligible for admission to say BSc General Group A. However, there are, if a person is good at cricket, now here good at cricket has imprecision about it. However, this type of knowledge is also frequently used in knowledge domains for solving problems. So what is a fuzzy rule we'll explain. Then we'll explain why a fuzziness is required for solving problems. Then we'll give some, like sets, which now onwards will be called crisp sets. Set theory which is taught in 9th, 10th or even earlier. We will have the parallels of that of fuzzies. We'll discuss all these things under next topic. And then we have the operations like union of sets, intersection of sets, complements of sets, etc. Similar operations are there for fuzzy sets. We'll discuss those. Then there are some operations which are quite new, which are unique to only fuzzy sets. We'll discuss some of these, and finally we'll discuss the fuzzy relation. We know there is a concept of relation in mathematics. So what is the corresponding relation in fuzzy mathematics, which we call fuzzy relation, and finally fuzzy logic. What fuzzy logic means is that while using fuzzy statements, how we come to new statements which can be concluded from the given statements is what we call fuzzy logic. It is like the crisp logic where we are given precise statements, and from those precise statements, using some forms of reasoning, we conclude new statements, and that is called your symbolic logic or just logic. Similarly, when the statements are not about precise entities involving, but rather it involves fuzzy concepts also, then the reasoning process have to be a bit different, and that reasoning process which leads to correct statements while using fuzzy statements is called fuzzy logic. So after enumerating the various topics, let us start with the first one. Please look at the slide. Here about 4 or 5 phrases are given. Healthy person, depressed patient, old young person, sweet mango, beautiful painting. Please let us look at each of these. Healthy person. Now it is very imprecise. You know, a person may be healthy who doesn't have any disease, can walk, talk and all that. A person is healthy who can run a marathon also. A person is healthy who can lift weight in hundreds of kilograms. A person is healthy who can study whole night and day. So there are various connotations implied by the word healthy. You can say the 4 or 5 types of healthy which I enumerated just now. A person who can just walk, is free from all diseases. A person who can run a marathon. A person who can study day and night for years together. These are different type of health indicators. However, the same word healthy is used in all these cases. So healthy has different shades or meanings, shades of meaning or connotations. Healthy is not a unique something. Similarly, depressed patient. Some of the patient may be so depressed that he or she may be on the brink of committing suicide. On the other hand, a patient may be just depressed, and after, say, talking to somebody for a while or so, may be okay. So these two degrees or two types of depressions in which one patient is just on the brink of committing suicide, and on the other hand, because of loneliness for a few minutes, and if somebody comes and depression goes away. These are two different type of depressions, but here are represented by the same word, depressed person. Similarly, old and young. Now these are again very imprecise. If you take an old person. Now, we cannot say a person of 30 years is old, is young, and a person above that is old. Or let us take, instead of 30, say 40. A person below 40 is young, but a person over 40 is old. How can it be? Just by adding 1 day to the age, 40 years, 1 day becomes old, and 40 years or 1 day less or any number of days less becomes young. A person doesn't become old just overnight. However, in general context, or rather, it representing a single unique thing, it represents a variation or range of things or concepts. Similarly, sweet mango. Now, sweetness depends, or you can say sweet milk. It may have just 1 spoon, say half kilogram of milk may have 1 spoon in it of sugar. It may have 2 spoons of sugar. It may have 5 spoons of sugar. All will be called sweet milk. But definitely these are different type of sweetnesses of the milk depending upon the number of spoons, and not only number of spoons but the person who is testing it. Some of the people feel just by adding a small amount of sugar just sweet. Others don't feel it sweet even after adding a number of spoons. So what I want to convey, similarly the beautiful. A painting may be beautiful for one person, it may not be beautiful for the other. That is, beautiful is a subjective term. It is not objective. And again, when we have 4 or 5 paintings which may all be called beautiful, there may be different degrees or different, one may be much more beautiful than the other. Still all the 5 pictures may be beautiful. So what I want to convey, each of the word healthy, depressed, old, young, sweet, beautiful, all are not actually representing a precise concept but a concept or a baggage of concepts each. So I hope you have understood. Now I take a phrase. So far we discussed the imprecision or fuzziness due to single words which are generally adjectives. Now you take a phrase for a long period. Friends, the three sentences or statements which are given on the slides, each show a variance by thousands of degrees. How the for a long period may be interpreted. The first says, dinosaurs ruled the earth for a long period, about million years. It has not rained for a long period, but only about 6 months or so. I had to wait for the doctor for a long period, about 6 hours. Please again look at the three sentences in which for a long period is used, but in the first case it is more than, I think, 65 million years or so, where a long period stands for. In the second case it may be standing for a number of months but not years, or maybe even years but not decades or so. And in the last sentence, a person cannot wait in a doctor's room for 6 months and then entitled to be called to saying that for a long period. No. Generally, if a person waits for 4 or 5 hours, it becomes a long period for a patient to wait in a doctor's room. However, for all these, a long period is used. What I want to emphasize, that in English language or in any natural language, a word or a phrase may be used for a variety of things, and this is why this is of course a strength of the natural language, but it becomes a problem also when used in context of solving problems with the help of computers. I hope it is very clear to everybody. Next, we consider some of the rules of driving. Please look at the slide. The rule says, if an obstacle is close, then apply brakes immediately. Now friends, here the word close, if the obstacle is close, this close doesn't mention whether it should be 50 meters, it may be 100 meters, it may be 1 kilometer, or it may be just 5 meters. Anyone may be, depending upon the sensors capabilities and the brakes applicability. Close depends upon that. Similarly, applying brakes immediately, whether it should be applied within 1 second's duration, whether it should be applied within 1 minute's duration, and so on and so forth. So both the words close and immediately are imprecise, and depending upon the person for whom these are meant, the close and immediately can be interpreted. Human beings rather, and one more very strange thing, we the human beings are not very comfortable with very precise concepts. Let us look at an example. If I say the sky is overcast partially, we are comfortable. But if I say the sky is overcast 37.3698%, hardly anyone will be able to get any meaning out of it. Rather, what I want to convey, that while using natural languages, we use fuzzy words, we get meaning out of fuzzy words, we get the idea about fuzziness, and we are better in getting ideas or meanings through fuzzy concepts, fuzzy rules, and fuzzy other things, instead of the concepts when those are very precise in many of the situations. I am not insisting in all situations, but in many situations human beings are much better in getting the appropriate meaning through fuzzy concepts instead of the very precise concepts. However, this is not so with the case of computers, because computers are generally manipulators of precise symbols through precise operations and all that, and therefore in the case of computers, that is the characteristic difference between the human computing and the computer's computing. I hope this is clear to all of us. It is hot and humid, the vegetable is not properly cooked. If I say, please look at the last 3 lines, it is hot and humid, we are very comfortable. But if somebody says that now the temperature is 40.7 degree and humidity is 60.89, then we are not comfortable. Just saying it is hot and humid, it is sufficient for us to derive our conclusions, to make our decisions, etc. Similarly, the vegetable is not properly cooked. We will not here use something like that 37.9 of the required it is cooked. It will rather confuse than telling us or conveying something to us. So, friends, once again, imprecision in language is not bad thing, at least for the human beings. But because now we are not solving the problems just by our own selves, but we are using computers also to solve problems, because the problems are generally very complicated and difficult just for the human beings only to be solved. We must use the computers, and there, as I mentioned earlier, computers are more comfortable with precise concepts, and therefore we have to find out some alternative, some via media where the human beings continue using the imprecise concepts, but whenever they are discussing or using computer systems for solving the problems involving these imprecise concepts, then there must be a mechanism through which the imprecise concepts can be given or conveyed to the computer systems. And here it is the fuzzy logic or fuzzy reasoning which comes into picture. Okay, I hope the very reason why the fuzzy logic or fuzzy mathematics is used is conveyed to you. Human beings are good in using imprecise language, whereas the computers are not good, and therefore fuzzy mathematics or fuzzy logic is used to do the desired, which is to complete the gap, to fill up the gap between the human way of thinking and the machine's way of thinking. Please read, these are very important. Computers are much better than human beings in solving problems involving complete and precisely definable entities and operations, but human beings are still much better than computers in solving problems involving incomplete, imprecisely defined information. What does this mean? This means that there are a number of areas in which human beings are still much better than the computers in solving problems. However, we want the computers also to be useful in solving that type of problems, so that the human beings are freed from this botheration of solving those problems in which at the time being human beings are better. So what is the media? As I mentioned earlier, we find various mechanisms like fuzzy logic, etc., which do the job of a bridge between imprecisely good or good in thinking imprecisely and the computers which are good in thinking precisely. I hope the idea is clear. Okay. Now, there are a number of examples which are given in which the human beings are much better than the computers. For example, just by looking at the eyes only and or nose only, we may recognize a person. That is a small fraction of the required information is given to recognize a whole object. Is it possible with the help of computers? So far it is not. Just by taking and filling a small amount of rice from a cooking bowl, we can judge whether the whole bowl of rice is of cooked rice completely or well cooked rice or not. Just by looking at a few buildings, we are able to see the area in which we are. For example, if we see, say, a already known place like Red Fort, if a person is all of a sudden put in just in front of Red Fort, one can conclude that I am in Delhi, I am in India, etc. That is just from a very small fraction, that is a single building. We can make a conclusion which concerns much more bigger thing. These are some of the things in which human beings are much better than the machines. However, we want the machines to be equally competent in these areas also, so that the human beings are freed from the botheration of solving problems involving this type of faculties, this type of capabilities also. In order that computers achieve the human capability in solve, etc., we will have to have mechanisms by which imprecise information can be represented in the computer systems. And fuzzy logic is one of the ways in which imprecise knowledge is or can be conveyed to the computer systems. Okay, so now please, unless we further refine and modify, as I mentioned earlier, the set of tall people, it gives an idea. But if it doesn't give a very exact idea, for example, set of tall people, how can we differentiate between various tallnesses of the different people involved in the set of tall people? And here, similarly, set of good human beings, etc. So one of the mechanisms, again I emphasize, is by associating some numbers with the tallness as degree of tallness. So these are some of the reasons because of which we study fuzzy logic. So now we come to, please look at the slide. The slide says, in Indian context, we may say a male adult is definitely tall if the height is 6 feet. Everybody should agree that in Indian context, a person, if his or her height is above 6 feet, particularly we are discussing only males, if the height is above 6 feet, if a person is less than 5 feet, then everybody will agree that such a person cannot be called tall. That is, such a person whose height is less than 5 feet is not at all tall. And in the other cases, if a person is say 5 feet 2 inches, we can say little bit tall. Similarly, if the person is 5 feet 6 inches, slightly tall. If a person is 5 feet 9 inches, reasonably tall. Please continue looking at the slide. Now we have used definitely tall, not at all tall, little bit tall, slightly tall, reasonably tall, to which we agree. Now how to convey these various words like definitely, not at all, a little bit, slightly, reasonably, mathematically? Because a representation has to be mathematical or formal in order to be acceptable to the computer systems. Now how to convey these various linguistic words, natural language words, definitely, not at all, a little bit, slightly, reasonably, in mathematical language? One way out is that wherever definitely tall is there, we say the degree of tallness is 1. When not at all tall, there we can say that degree of tallness is 0. And in other cases, the degree of tallness may be varied as the words from a little bit we go to slightly, and from slightly we go to reasonably. We go on increasing. Ultimately, when we got the definitely, we say 1. I hope you understand. So what we can do, that this slide may be read again as like this one. That is, definitely tall may be assigned a value 1, not at all tall may be assigned a value 0, and similarly a little bit may be assigned a number 0.2. Slightly tall may be assigned number 0.4, which should be more than 0.2. And reasonably tall may be assigned another bigger number but less than definitely, that is 1. We may assign that reasonably tall may be assigned a number 0.7. It is not a question of 0.2, 0.4, 0.7, etc. No. Depending upon the question under consideration or situation under consideration, numbers may be associated with a linguistic variable between 0 and 1. And that is where the fuzzy logic comes, that now the word tall may be distinguished by the degrees associated with the various heights, And depending upon the degree, we interpret it as the degree of tallness. And it is quite fair now. A person of 5 feet 2 inches is definitely having a degree of tallness less than a person of height 5 feet 6 inches. And therefore we associate a degree say 0.2 for 5 feet 2 inches, and we associate a degree 0.5 for a person with height 5 feet 6 inches. And this is adopted in case of all other linguistic variables, adjectives, etc. If you add 1 spoon to half kilo milk, we can say degree of sweetness because of this is 0.2. And similarly, when we add 2 spoons, the degree may become 0.6, and so on and so forth, depending upon the taste and many other things. So this gives rise to the mathematics of fuzzy reasoning. I hope the idea must be very clear that how to handle the linguistic variables like sweet, good, beautiful, etc. by assigning numbers between 0 and 1. Please read the slide. Coming back to the imprecise concept of tall, let us think of the male persons of an organization, say 5 persons. Now, how this concept of fuzzy may be used in solving problems? For that purpose, we are taking 5 persons of an organization. The names of the 5 persons are Mohan, Sohan, Johan, Abdul, Abraham, whose heights respectively are 5 feet 2 inches, 6 feet 4 inches, 5 feet 9 inches, 4 feet 8 inches, 5 feet 6 inches. Friends, as we discussed earlier, a person of 4 feet 8 inches, that is Abdul, cannot be said to be tall by any measure, and therefore the degree of tallness to be associated with Abdul is 0. Whereas the Sohan, who is 6 feet 4 inches, can be said definitely tall in Indian context, and therefore the degree of tallness which can be associated with Sohan is 1.0. So what I mean to say, earlier the set of tall persons in the organization is only Sohan. But you can't say that the person who is having 5 feet 9 inches height is also not tall, at all tall. That is, once a person crosses a particular height at a particular point, he or she becomes tall and others are not tall. That is quite unreasonable. And therefore, instead of saying that the set of tall persons in the organization is equal to Singleton Sohan, we like to say the more appropriate representation will be something like this. Please look at the next slide. Now, everybody is there in the set of tall persons, but with the difference that everybody has an associated degree of tallness with it. Now, Mohan being 5 feet 2 inches in Indian context is maybe slightly tall, and slightly is replaced by 0.2. Whereas Sohan, who is 6 feet 4 inches, is definitely tall, has been associated in number 1. Similarly, Johan being 5 feet 9 inches has been associated a degree of 0.7. However, Abdul being 4 feet 8 inches in Indian context is not at all tall, and therefore the degree of tallness which has been associated with Abdul is 0. And Abraham, who is 5 feet 6 inches, something like that, his tallness degree is 0.4. So now you can see the earlier one, the set of all tall persons which included only Sohan, is replaced by a set of tall persons but with associated degrees, is much more informative, much more useful in solving problems with the help of computers. I hope the idea must be conveyed, which justifies the study of fuzzy logic. Now, we may, when we discuss, instead of tall, we discuss short persons. Now, in our intuition, short is just opposite of tall. So, a person whosoever is definitely tall is not definitely short. That is, if someone is 6 feet 4 inches, his degree of tallness is 1, he is definitely not short. That is, the degree of shortness should be 0. Similarly, Abdul, who was 4 feet 8 inches, was not at all tall, is definitely short, therefore his degree of tallness was 0, his degree of shortness should be 1. What this discussion tells us? This tells us if you have an antonym, you can obtain the corresponding fuzzy translation just by subtracting the degrees from 1. The opposite of tall is short, and from the information about tallness you can derive the information about shortness. And this is what is reasoning meant for. That is, you are given some information pieces, but you don't need that information in that very form in which it is given. Rather, you want or you need in some different form, and that is the reasoning process. And here fuzzy logic tells us how to derive shortness from tallness. And one mechanism, as I just now suggested, that subtract the degrees of tallness from 1 and you get the degrees of shortness. And according to that criteria, Sohan, who was tall, definitely tall, having degree of tallness as 1, must have degree of shortness 0. So the set is short becomes Mohan is short by 0.8 degree because his height 5 feet 2 inches is very slightly tall. That is definitely short, not very definitely short, but quite good short. And therefore the degree associated with shortness is 0.8. And you can see the similar. Abdul, being 4 feet 8 inches, was having degree of tallness 0. So he should have degree of shortness 1. So please read the last 2 lines and you can understand how fuzzy logic helps us in finding out information pieces which are not directly available. We are given tallness, we want to discuss in the solution of some problem shortness, and shortness can be derived by using the tools of fuzzy logic like this, as I have discussed now. Now, as I mentioned, now the concepts which are not very precise of natural languages have been replaced by sets of ordered pairs. Each pair consists of the name of the person and the second component of which contains the tallness degree. In general, if there is any other concept instead of tall, and there is a set of entities involved, what we can do, we can think of a set of ordered pairs in which the first component is the entity and second component is the degree in respect of that linguistic variable. So what does this mean? This means linguistic variables can be thought of as sets. However, here the sets don't have ordinary members, rather ordered pairs, in which the second component is a number between 0 and 1. But ultimately it is a set. So it gives us a hint that whatever operations are there on sets, can we have similar operations on the new type of sets which we call fuzzy sets. The new type of sets in which each element is an ordered pair, in which the second component of the ordered pair is an integer, is a number between 0 and 1. This type of sets are called fuzzy sets. But ultimately these are sets, therefore whatever are the operations of union, complementation, intersection, etc., which can be applied to ordinary sets which will be called crisp set for this discussion. The operations of union, intersection, complementations are applied to crisp sets. Are there corresponding operations on the fuzzy sets whose elements are ordered pairs? Yes, there are. Now let us discuss what is the shape of those operations particularly of union, intersection and complementation when applied in context of fuzzy sets. But before that we know that there is a concept of subset. We know when A and B are two sets, A is said to be a subset of B if every element of A is an element of B. Now, but in the case of fuzzy, every element is present as a first component. So here, how to discuss the subsetness of two sets, one fuzzy set with reference to another fuzzy set. So friends, if we go back to our example of tall, we know that if the degrees are reduced, then these give indication of reduced property of tallness. So this suggests that in the case of fuzzy sets, it is the degrees which determine the subsetness or not. So taking into consideration this one, if we have three sets, first of all we discuss what is meant by subset for a crisp set. From this example we know A is equal to B because every element of A is in B and every element of B is in A. However, the set C is not related to A and B because this has an extra element 2 and it does not have an element 3 which occurs in AB. That is, C is neither related to A nor related to B, vis-a-vis containment. However, A and B are equal. Now we are discussing the corresponding definitions for fuzzy sets. So please, now you see, let A be, please look at the slide, A is the set of tall persons with associated degrees, B is another set in which the different persons with different degrees occur, and C is another set where the degrees are different. Now in this particular case we determine the equality in terms of the associated degrees because the elements are same in all the three sets. So here A is equal to B because in A, Mohan has degree 2 of tallness, Sohan has degree 1, Johan has 0.7 and Abraham has 0.4. So in both these sets the associated degrees are same, therefore we can say as fuzzy sets these two sets are equal. However, in the case of last set, you see Abraham has degree 2 associated with it in set C, whereas in set B 0.4 is associated with Abraham, therefore the degrees are different and degree is less in C. But on the other hand, Mohan has degree 0.2 in B, whereas Mohan has degree 0.4 in C. So one element has more degree than the corresponding element in the other and vice versa. Therefore there is no comparison of the two sets B and C so far as containment is concerned. I hope the idea is. Now we know if instead of just tall we discuss the concept of very tall. Now common sense tells us that the very tall persons, their set must be a subset of the set of tall persons. However, on the other hand, the degree of very tallness will be less as compared to the degree of tallness. I clarify it further. For example, if a person of 6 feet is tall, then if we discuss very tall, then the person of 6 feet has lesser degree of very tallness and maybe say that he is very tall to the degree of 0.8, because we may say a person above 6 feet 6 inches is definitely tall. However, below 6 feet 6 inches the person may be assigned degrees of very tallness. What I want to convey through is this. On one hand, through the common sense, we have the set of very tall persons is a subset of the set of all tall persons. Everybody should agree, because a person to be very tall must be first of all a tall. So every person who is very tall is a tall person, therefore the set of all very tall persons is a subset of the set of tall persons. I hope it is clear. On the other hand, as very is included, the degrees which are associated earlier have to be reduced. A person of 6 feet is definitely tall, but not definitely very tall. The degree has to be reduced. So what this conveys, this whole discussion conveys, that in order to discuss the concept of subset, it should be discussed in terms of the degrees associated. If in one set all the elements have degrees associated which are less than or equal to the degrees associated in another set to the corresponding elements, then the first set may be said to be a subset of the other set. It is through pure common sense. And once we have said, please read the slide, the degree of tallness of a person, say 0.5, then degree of very tallness will reduce to 0.3. And continuing like this one, we come to the conclusion of the definition of subset for fuzzy sets. If A and B are fuzzy sets on the universal set x1, x2, xn, then A is said to be a subset of B. If the associated degrees Vi are less than equal to the associated degrees of Wi in B, and if it happens for every element x1, x2, xn, that is the associated degree in A, that is Vi, is less than Wi, which is the degree associated with Xi in B, then we will say A is a subset of B. Please look at the slide. Whatever idea I have conveyed or spoken is written over there on the slide. Please read it. Now here in set A, Mohan has 0.2 degrees, Sohan has 1, Johan has 7, Abdullah has 0 and Abraham has 6. However, in set B, Mohan has degree 0.2, Sohan has 0.8, whereas earlier it is 1. Johan has point same as same, Abdullah has 0 in both the cases and Abraham has 0.4 instead of 0.6. So you can say that the degrees associated in set B are less than the corresponding degrees in the set A, and therefore we can say by this definition that B is a subset of A. This is how we have captured the concept of fuzziness. Similarly, we can have the other operations like union and intersection. For this purpose, we should know that every set can be considered as a fuzzy set by associating degree 1 with all those which are present and degree 0 with those which are not present. However, every fuzzy set cannot be considered as a ordinary or crisp set. So I have briefly told you some of the important ideas behind introducing the concept of fuzzy, and time permitting we can discuss the operation of union also in the context of fuzzy set. For that purpose, please look on the next slide. Please, next slide is saying this is the next slide. Yeah, here. Please look at the slide. The slide says that if you want to have the union of two sets, then what we do? We write all the elements of A and B. Here what we can do, in the case of fuzzy, what we do is that we take the maximum of the degrees of fuzziness from the two, and that is associated. Please look at the example. Here C and F are two sets in which the associated degrees are there. Their union is obtained by taking the maximum degrees associated in the two sets. So Mohan has associated degrees 0.85 and 0.75. So in the union 0.85 is associated with Mohan. Similarly, Sohan has degrees 0.6 and 0.4. Here the degree with Sohan which is associated is 0.6, and so on and so forth. And in the case of intersection, we take the minimum of the 2 degrees which are associated with the element in the two given sets, and that gives the intersection. So friends, a very brief idea of why fuzzy sets are studied and what are the parallels between the fuzzy sets and the crisp sets, like intersection, like complementation, like subset, etc. I have discussed. In some later lecture we will find out the applications which are required for this. For this purpose you can have a number of very good books on fuzzy logic, and you can look at our website for the references. Thank you very much.